Assalamualaikum and hi everyone. So today we are going to take a look on how to draw the ERD based on the sample question here that we have. So let's read the question first. The first thing that you need to do is make sure you can extract as much as possible requirements or what we can say understand the question first. Okay, so study the table A below. We have registration receipt here, student ID, student name, parent's name, parent's phone, course name, staff ID, and staff name here. So a receipt as shown in table A above is an example of receipt received by the students once they registered in college to it. The college is still using a manual system in order to register their students into courses that they're interested in, and it consumes a lot of queuing time, especially during the peak season. As the database engineer, you are hired to develop a database system according to the requirements given by college to it. So students can register any courses available given by the institution as the first requirement. Then many staff can handle students' registration at one time. Each staff will have their own manager and divided according to admin or lecturer post. You need to design a cross-foot ERD together with its modality and kernelity. You can add on data based on the assumptions. So if you take a look at the last statement here, you can add on data based on the assumption means since there are not much attributes given. Okay, there are not much attributes given. So it means we can assume the attributes in a table that we are going to have on our own. Okay, because only few attributes here listed. For example, student ID, the student name, and so forth. Okay, so first things first, let's take a look on the table. So based on this table, what we can say, student ID and student name is, we know that we will have table student. Then parents name, parents phone can be under parents table. Okay, parents table. Then course name, of course, we will have table or entity course. Then staff ID and staff name could be under staff. Okay, so if you take a look here, students can register. Take a look at the requirements. Students can register, so means there will be a registration entity. Okay, student can register any courses available. So students will register the courses, okay, available. Then many staff handle the registration. So we know that staff will handle the registration. Okay, then each staff will have their own manager and divided according to admin or lecturer post. So it means staff can have manager. So one staff can manage many other staff. So this is a recursive relationship. So we know that there's a recursive and the staff are divided into admin or lecturer. So admin or lecturer. So this one, maybe we have the inheritance over here, the superclass and subclass. Okay, so let's try to understand these requirements and make sure you can extract all of these entities out of the requirements based on the question given. So now let's take a look on how to draw the ERD. So if you take a look here, student can register any courses available. So it means many students, many courses. So of course the registration would be the bridge in between student and courses. So by right we will have students. Okay, so we will have students. Okay, so inside the student we have primary key of student ID. Then maybe you have student name. Since you can assume data on your own, so maybe you add student email, for example. Okay, so one student will do many registration. Okay, so this is we have registration. So of course one student, many registration. So inside here maybe you have the registration ID, the registration date. Okay, and what student will register? Student will register the course. Okay, so now we have student register course. Okay, so now we have the courses database here. So one course will be available in many registration. Okay, put a relationship name. Okay, student has registration. Okay, so if you take a look here, what's the PK inside courses? We have course ID, and maybe we have the course name. Okay, so if you take a look here, let's take a look on students relationship first. One student has many registration. So how many maximum number of registration? Okay, here we have many. How about the minimum number here? The modality. So one student can register at least one. Okay, register at least one. And if you are in table registration, the minimum number of students here should be also one. So this registration belongs to one student. Okay, so if you take a look here, we have the cardinality and modality for these students and registration. But how about if you take a look, one relationship, you need to have the foreign key. So for this hash relationship, you need to have one foreign key. Where to put the foreign key? Between students and registration. So of course at registration. Why? Because the registration is at many side over here. So now we have one FK. So what's the FK here? FK is a primary key of another table. So another table that attached to is student. So what is the primary key here? Student ID. So that's why we have student ID over here. So now let's take a look on is available relationship. If you take a look, one course will be available in many registration. That's the maximum part. Okay, so this is the maximum part. How about the minimum one? One course will be available in minimum how many registration? Okay, so I would prefer to put the number here is 0. Why 0? Because it is logic to have a course that is not registered by any student. Okay, so that's why the number here could be 0. However, if you are in the registration table, then of course there must be a course over here, at least one course. Because why? This is a student registration system. So of course the student needs to register a course. Okay, if not, they cannot be inside the registration table. So if we take a look, as I said, one relationship, you will have one foreign key. But where to put the foreign key for this is available relationship? It is in between registration and course table. So where to put? We'll put inside registration. Why? Registration is at many side between this relationship. So we will have another foreign key here, which is the course ID. Okay. So by right, now we have finished with the students, registration and course, the different student, course and registration. So let's move on to another entity, which is parent. So if you take a look based on the registration table here, the receipt that we have here, students are related to the parent. Okay, so of course we will know that one parent or the parent will have many students. Okay, so that you will know student will have relationship with parents over here. Okay, we have table parents. So what is inside the parents? The primary key, maybe we have parent ID. Then we have the parent name. Take a look inside here, what do we have? Parent phone. Okay, so make sure the basic attributes inside the receipt is there lah. Okay, then if you take a look, one parent will have many students. Okay, so how about the minimum number? One parent will have at least one student. If there is no student, how can the parent be inside the database of this college? Okay, then a student also should have at least one parent. Okay, so parent owns the students. Okay, so by right, if you take a look, as I said, one relationship, one foreign key. So where to put the foreign key? In the many side. So what is the primary key here? Parent ID. So by right, we will have a foreign key of parent ID here. Okay, we have the relationship of between parents and student. Okay, so I believe we have finished with the course, we have finished with the student and parents. So now we have another one, which is staff. So what's the relationship of staff? So if you take a look here, many staff can handle students' registration. So it means we have a relationship between registration and staff. Okay, so if we take a look here, okay, one staff will handle many registration. Okay, so if you are a staff, the foreign key should be staff ID. And what else we have? Staff name. Maybe you have the staff salary and so forth. Okay, so let's say we put only 3 over here. So one staff will handles many registration. So not every staff will manage the registration, because maybe you are the CEO and you are the staff, but you don't handle the registration. So the minimum number can be 0 over here. Okay, then if the registration must be handled by at least one staff over here. Okay, so we know one staff handles 0 or many registration. So as I said, one relationship, we have one foreign key. So where to put the foreign key? On the many side. So the foreign key over here that we can have is staff ID. So even though it looks like we have all of the entities listed over here, okay, the student, parent, course, staff and registration, however, we haven't finished with the requirements. If you take a look, each staff will have their own manager. Okay, so what does it mean here? One staff will manage many other staffs. Okay, so we actually have the recursive relationship over here. One staff will manage many other staffs. Okay, so if you take a look here, manager is also a staff, so that's why we don't need a manager entity over here. Okay, what if you are the manager, you will manage many other staff, but not everybody is a manager. So that's why if you are not manager, you will manage 0 staff, and if you are a staff, you have at least one manager over here. Okay, so in a relationship, as I said, we need to have the foreign key. So where to put the foreign key? Inside this table also. Okay, since you are attached to the relationship is attached to the same table, so we will have a foreign key over here. But what is a foreign key? Primary key of a table. However, as I said, we cannot put staff ID here. It violates the properties of relation, which is attribute names cannot be the same. So hence we can change, instead of staff ID here, we can change it to become manager ID. But we know this manager ID is referring to the staff ID. So this is for the recursive relationship. And if you take a look here, the staff are divided into admin or lecturer post. Okay, so means we can have another admin and lecturer entity here. So in the admin, so we have another one is lecturer. This is also an entity. So this is the superclass and subclass. They are referring to the superclass over here. So what is the superclass here? Is the staff. So inside here, okay, inside admin and inside the lecturer, I would prefer to have the PKFK of the staff ID, because we know that this admin is referring to the staff. And also inside the lecturer, we also have the PKFK, which is the staff ID. Then inside the lecturer, maybe we can have another attribute, which is expertise of the lecturer, or maybe the research core of the lecturer. Okay, then for admin, maybe we can have, admin may have the typing speed, okay, the typing speed and attribute, and any other attribute that is uh, only specific to admin. Okay, then how about the constraints over here? So the constraint over here, the first one I would prefer to put as optional. Okay, why optional? You can just be a normal staff, you can be the admin, or you can be the lecturer. So means these three entities are possible to the staff. You can be just a normal staff, or you can be an admin, or you can be a lecturer. So how about admins and lecturer here? I put here or. What does it mean? Admin is not a lecturer, lecturer is not an admin. Okay, so looks like we have finished with all of our ERD. Sorry, if you take a look here, we have all the entities, we have the attributes, we have specified the primary key, the foreign key, the cardinality and modality, the maximum and minimum number over here. Then we have the relationship names, we have the recursive part, and we have the superclass and subclass part. So if you got this one correct, so of course we get full marks. Okay, so this is the basic on how can we draw the ERD based on the sample question here. So that's all for now. Thank you.